Hi guys, so we're going to be doing solving rational equations. We're going to do 3 examples, so have a pen and paper ready or a pencil and paper so that you can write these down. So for our first one, we know that the first step is always to factor the denominators if we can. In this case, we can't, so we want to find the LCM, also known as LCD in this case, least common denominator. So I can't factor x plus 1. I'm going to put it in parentheses. Same thing with the second x plus 1. And this 3, if I was to make it into a fraction, is really over 1. Okay, so the first 2 fractions are fine. They're matching. The third fraction, what does it need in the denominator? Hopefully you said x plus 1, so we're going to multiply in the x plus 1, and remember, whatever you do to the denominator, you have to do to the numerator. So now they all match, they all have an x plus 1. This 1 in the front here doesn't change the value of x plus 1. If you distribute it, it's still x plus 1, so they do match. Our next step, once we have all the denominators the same, we can actually cross them out and just figure out and solve for x using the numerator. So we have x plus 3x plus 4 equals 3 times x plus 1. We can combine like terms, which would give us 4x plus 4 equals, I'm going to distribute the 3x plus 3, and now solve for x. Hopefully you got that x is equal to -1, but you're not done. The most important part is that we have to check it. So really the only thing you have to do when you're checking it is make sure it works in the denominators. Okay, so if I tried to plug in -1 into any of the denominators, let's just try the first fraction. That would give me, so I have x over x plus 1. If I plug in the value of -1, that would be -1 over -1 plus 1, which would actually make -1 over 0, which doesn't work. So if it doesn't work in any of the fractions that you have in your original equation, then that value cannot work. And in this case, since that doesn't work, there is no solution. That's why it's so important to check, because if you don't check, then you might get the question wrong, because sometimes when you plug the answers back in, remember this is called an extraneous root. So when you plug it back in, it makes one of the fractions in the denominator 0. Therefore, you don't count it as a solution. Okay, so we're on number 2. So same thing, I have the steps right over here to the right. So first step, we want to factor the denominators if we can. So I'm actually going to rewrite this. So the first one, we can factor by difference of 2 perfect squares. So let's write that down. This one we could factor by dots. I can't factor a plus 5, so I put it in parentheses. I can't factor a minus 5, so I put it in parentheses. So we're going to rewrite this just to keep our work organized. So I have 2a to the second over, and when I factor a squared minus 25, that leaves me with a plus 5 and a minus 5. Then we have our minus sign, a over a plus 5. Okay, I'm going to leave a little bit of space next to it, and I'm going to put my equal sign and 7 over a minus 5, and again leave a little bit of space next to it. Okay, I'm going to explain why in a second. So if I use my matching game and I match up what are the common factors, the first fraction has an a plus 5, the second fraction has an a plus 5, but my third fraction is missing an a plus 5. So I'm going to multiply it in to the numerator and the denominator. Okay, so now all three fractions have a plus 5. So that's the first part of my LCD, is that they all have a plus 5. Now, the first fraction also has an a minus 5. The third fraction has an a minus 5, but the second fraction is missing it. So we're multiplying in a minus 5 in the numerator and the denominator. So now they are matching. So now all three fractions, and if you want to look at it a little bit easier, this is your first fraction, your second fraction, and your third fraction. They all have a minus 5 and a plus 5. So that's what I'm going to add to the LCD, is a minus 5. Okay, so that's my LCD. What is my next step? Hopefully you said to cancel out the denominators. So remember, that's the whole point. We want to cancel out the denominators once they're the same and just work with the numerators. So we have 2a to the second minus a times a minus 5 equals 7 times a plus 5. Okay, I'm going to skip ahead a little bit and I'm going to ask you guys to write down what you got for this question. All right, so hopefully when you distributed, you got a squared minus 2a minus 35. You can check the work here if you did not get that, but you always want it equal to 0, and you always want to factor and then solve. So two numbers that would multiply to negative 35, but add to negative 2, I'm going to factor it over here, would be a minus 7 and a plus 5. Because negative 7 times 5 is negative 35, but when you add them, you get negative 2. Equals 0. You do your t-chart and you solve. So remember, when you're solving, that means you're setting each factor that you have equal to 0. When I bring over the 7, that would leave me with a equals 7. And when I bring over the 5, that would leave me with a equals negative 5. Okay, we're not done until you check it. So sometimes it's easier to compare it to the factored version because you can easily just quickly plug it into the factors. So 7 actually works when you plug it in, so that's definitely one of our answers. If I plug in negative 5, though, into, let's say, this factor, that would make that 0, and 0 times negative 5 minus 5, which is negative 10, is still 0, which would make that whole denominator 0. So negative 5, when I check it, does not work, so the answer would just be 7. Okay, so remember, this is considered an extraneous root or solution. Okay, root, solution, they mean the same thing. It's interchangeable, but it's an extraneous root and an extraneous solution. Okay, so this is the last question. I still have the steps up on the side, so you can check those if you need to. So our first step is to factor the denominators if we can. Which denominator can we factor? Hopefully you said the third one. So the first two were just x minus 2x plus 4. We can't factor those. We put them in parentheses. The third fraction denominator we can factor by am. So two numbers that multiply to negative 8 but add to 2 are positive 4 and negative 2. Now we're going to go in and highlight. So again, play your matching game. See what they have in common. I see an x minus 2 in the first fraction and the third fraction, but it's missing in the second fraction. And I see a x plus 4 in the second fraction and the third fraction. So you multiply in the ones that they're missing. Okay, I'm going to skip ahead and I will show you guys the answer. Okay, so hopefully you can see I multiplied in an x plus 4 into the first fraction. I multiplied in an x minus 2 into the second fraction. And the third fraction already had the LCD. So in this case, our LCD is x plus 4, x minus 2. Okay, so it's what they have in common. Now they all three fractions have a denominator of x minus 2 and x plus 4. So now that their denominator is all the same, okay, x minus 2, x plus 4, x plus 4, x minus 2, x plus 4, x minus 2. It doesn't matter the order because commutative property of multiplication. But now remember, this is the nice part for solving. You can actually cancel them out and figure out the equation using just the numerator. Okay, so take a second, distribute, simplify, and get it equal to 0. All right, so you should have gotten x squared plus 2x minus 8. Now we can factor that. Two numbers that multiply to negative 8 but add to positive 2 are positive 4 and negative 2. Once you factor, you do your t-chart with all your factors. In this case, there's only 2, and you would solve for each one. So x plus 4 equals 0, x minus 2 equals 0, and then you get your x values. So in this case, x equals negative 4, and x equals 2. So we're not circling anything yet because we have to do what? Hopefully you said check. So we're going to check each of them. So we're going to check x equals negative 4, and we're going to check x equals positive 2. So remember, the easiest way to do this is to see if when you plug it into any of the factors, any of the LCDs, would it make 0? Okay, so your two LCDs are right here. X plus 4, x minus 2. If I plug negative 4 into either of those factors, it would not work because it would make this factor right here, the x plus 4, it would make it 0. Okay, so x cannot be equal to negative 4. Same thing for 2. If I plug 2 into any of the least common denominator factors that has an x minus 2, it's going to make 0, which cannot be. So x cannot be equal to 2. So in this case, there is no solution. Okay, because both of these, draw an arrow here, are extraneous solutions. Okay, hopefully this helped. You have 2 questions to try on your own, and I will see you guys tomorrow. Have a great day.